All right, we should be live. Let me know if you can hear me, and I'll go ping the Discord. Then 1 second. Hey, Bacon. Can you hear me all right, Bacon? Cool. All right, I'll just jump right in, and so yeah, we'll see who joins. If I remember correctly, we had a not working version of print uint at the end of yesterday's stream, and today I intend to fix that if possible. So that'd be in here, right? Yes. And when we were running this thing, I think, hey, Antcraft, Nasm, L64, print uint. Oh, I needed to link them together, right? Because it references some other things. Which other things? Print char, okay. So do that and print char.o. There we go. Now if I do print uint, yeah, we're getting this number where we had wanted to see, I think our number was like 1, 2, 3. Yeah, 1, 2, 3, 4, 5. So we're wanting to see this, but we're seeing some apparently random number. I wonder if I were to change this. So this was 4202496. If I were to change this to some other random number, would this change? No, it's still the same. That's interesting. So we're getting the same number regardless. So I think it's probably time to debug this. Hey, Stefan. Is it Stefan, Stefan, Steven, or something totally different? I'm curious. 'Cause you're in Romania, right? And so I'm assuming pronunciation's probably different than I would assume. Alright, so I'm going to change this back to 1, 2, 3, 4, 5. And then yeah, we'll debug this. So I'm going to do this again. Dash G, right? And then dash big F, dwarf. Pronunciation you want, I don't care. Stefan or Steven is fine. Okay. I am curious though, which is like correct. We'll do that, and then LD would be the same command, right? We'll do that. All right, so now we have with debug symbols, and we'll try debugging this. So we'll LLDB, what is it? Print uint, right? Cool. So now if I breakpoint set at start, then we have one there. Now we can run until start. Okay, so we should have moved test number into RDI, or a pointer to test number, correct? So if I were to register read, hello nameless bystander, if I were to register read RDI, we get this, which is a pointer to test number. I'm gonna say Stefan with an intentional stutter to make it sound posh. Okay. And then, all right, so we have that. So we'll step now. We should call print uint. So now we're in our function. So we move what was in RDI, which is this 402 pointer thing, which should have been moved into RAX now, right? Register read RAX, right? Perfect. It got moved into there from this line. And then we push 10. Is the doc to the left a book you have as a PDF? Yes, exactly. It's Low-Level Programming by Igor Zirkov. Here. There you go. Okay. And then what do we do? Okay, I'm just gonna step. So now I step again. We jumped all the way to line 17. Is that just because I had a bunch of comments? Let me see here. Line 17. I'm gonna make this big so I can do, oops, this. Cool. And then over here I can have this. Okay. Line 17. So we jump down to here. Isn't that one too many? Why did I skip this? Because I was on push 10. And then I just hit step. And it skipped all past all this and went to here. I feel like it should have stopped here, no? You don't think I should input a pointer? You think I should input like the raw value? Or but the debugger thing is weird. Yeah, I don't understand the debugger thing. Oh, am I not treating this as a pointer later on? Because that would explain why it's not working. Because wait. RDI, so now REX holds a pointer. And then, oh, and then I'm just dividing the pointer. Oh, you're totally right, in craft. I'm treating the pointer as if it were the actual value itself, aren't I? And I need to, okay. This is interesting. So instead, could I just do this? Like move our number in here? And then not do this? I wonder if that would work. Let's try this. Alright, I'm going to stop doing this, and then let me say we'll do the same NASM thing here, and then link it, and then print uint. Whoa. That was totally the issue. Check it out. 1, 2, 3, 4, 5. That's super cool. So that was my problem, is that I was using a pointer instead of a real value. Yeah, I mean, it might be nice if you printed a new line, but who knows where we're going to want to use this, so we won't do that for now. So that means this, what is this? GitHub desktop, okay. This is done. No, this is done, that's what we just did. Cool, so we want to print int. All right, now we need to output a signed 8-byte integer in decimal format. Ooh, okay, this is tricky. We'll give it a shot though. Let me there, do that. I'm gonna make a print int dot asm. And what's our assignment? It's to do this. Why are we using one file per function? Doesn't this make the linking more annoying than necessary? It does make the linking more annoying than necessary. Why I'm doing it? I forget. Originally it was like this, all in one file. But then I started writing like my own tests, and so then I was just like writing different things in the start to test it out. And so I feel like I'd have to I'd be changing this all the time, but it might be fine. I could combine them all. So when you started learning low level x86. So from who you learned that? I'm using the book. It's right up there in the chat. This one. That's what I'm using. All right, you're saying I should put these all together in one. I can get on board with that. Put them all inside a header file or something? What does that mean? Is that like a C header file? I'm just gonna keep going like this for now, just to keep it simple. And then I don't mind linking two things. It's not a big deal, I don't think so. So global start section text. And then I'll have start. Cool. So print int to see thing. Yeah. Okay, so I'm not even clear on output a signed 8-bit integer in decimal format. So integers that are signed use that thing. What was the process? So if I have like if I have like an 8-bit, if I have 1 here, and then I wanted to make it negative, you do the thing where you invert all the bits and then you add 1, right? And that's called the 2's complement. Use the most significant bit to represent the sign. 2's complement. Well, which one? The use the most significant bit to represent the sign, or the 2's complement? So this is -1. Because if this is -1, my question is, how do I know this isn't like 1, 2, 4, 8, 16, 32, 64, 128, like some giant number, right? Or what would it be, 255? Two's complement also gives the sign bit automatically. Do we need ordinary differential equations for that? I sure hope not. Depends on the type. So if I'm just told, hey, here's a signed int, and they say here it is, then how do I know whether this is 255 or -1? Right? That's my question. Depends on the type. Unsigned int would be the big number. Signed int is a small one with a sign. Oh, so signed ints, you're telling me signed ints are always negative? I thought signed meant it could go either way, and unsigned meant it is always positive. But a signed int is always, by signed int they mean like a negative int? Is that what they mean? Because that would make sense. If you know that it's signed, you can check the signed bit. Signed positive 255 cannot be represented by 1 byte. To know if it's -125, you're being told by the user. Check the signed bit. Signed positive 255 cannot be represented by 1 byte. Signed goes from negative. Okay. So if I have the number 127, positive 127, it looks like this, right? It's like this. No. It'd be this. Yeah. So you'll need a print unsigned and a print signed. I already have a print unsigned. I think people use linear algebra for stuff, but I haven't used any of either of those yet. Okay, wait, so I'm trying to wrap my head around this. If I have, so if somebody gives me a byte and it looks like 100100011 or something, I instantly know this is negative because this is a 1, is what you're telling me? Yeah. I think I get that now. Okay, so you said this means I know this is negative right off the bat. And then how do I figure out what the value then is? Yeah, so if I know this is signed, if this is signed, then this is negative something, but then I have to like undo the 2's complement to find this out, right? What this actually is, because it's not just 1 plus 2 plus 16, or is it just that, -19? Is this -19, or is this negative something else? 2's complement works the same way backwards and forwards. Negate the whole value and add 1. By negate, do you mean like flip the bits? Like 0, 1, 1? 0 1 1 0 0. So we flip the bits and then add 1, and then you get 0 1 1 0 1 1 0 1, and then this is the positive int. That's the absolute value of the actual number, and so this is like 1. Wait, what is this, right? It's like 1 plus 2 plus 4 plus 8. That's like 13 plus 32. It's like 45 plus 64. So it's like 111 or something, 109. So this is negative 109. Is this correct? What I just did here? Yeah, it reverses polarity. Is this correct? I got it? Okay. Minecraft says I got it. Alright, so I'm going to use this method. If given a signed int... Oh, wait. So here's another problem. If I also get another signed int, but it doesn't start with a... Hello, Astro. But it doesn't start with a 1. Like, say it's like this. Right? Do I still have to do the 2's complement on this guy, even though he's positive? I still do, right? If I'm told he's signed. Or is... No, it's already positive. Okay, so if it's already positive, I don't need to do that. But I do need to do the 2's complement for the negative 1. So this one's just 1 plus 2 plus 4, right? So 7. So this one's just 7. This one's negative 109. So this is it. This is what I need to know. Okay, I'm going to keep this down here because this is important. This can be deleted. Awesome. Thank you, guys. So I'm going to have some function that's like print int, right? And it's going to do something. But it'll take an int. So, and probably an RDI, right? So we'll move how do you do binary? Is it like 0b? Is that right? How do I just write raw binary? How can I write an immediate binary value in NASM? Zero B. Okay, that's what I thought. So I'm going to move into RDI 0B. I'll do a couple tests, right? So first, signed one. So this one we decided was negative 109. 1 0 0 1 0 0 1 1. Oh, but this is just a byte. Do I have to do that like byte? The byte dance, right? Byte dance. Is that how you do it? Move byte? I think that's the syntax. If I want to specify that I'm just moving 1 byte, do you write move byte? Like this, move byte. Oh, but do I need that? Oh, does that only apply to memory? It just works for registers, maybe? Oh, okay. So I'll try that. So this should be negative 109. And then we'll yeah, where is Xylo? He told me he had a lot going on, and so he wasn't going to be quite as active going forward with this project, but I'm sure he'll be around somewhat. Move RDI that. Okay, and then we're going to call excuse me. We're going to call print int. Right, and then that should print out a negative 109. And then we're going to do kind of the same thing, but we'll use our 7 down here. So this should be 7. This should be positive 7. And then we will call print int. And then we'll just exit, right? So cool. I already sort of know I'm going to want to use print uint. Not that, but print uint.asm. Because I can just call out to this to actually, once I get the 2's complement of something, then I can yeah, because then I could just print out the minus and then call out to print uint to print the like this part, right? So that'll be pretty easy. So we have a number in RDI. Now I want to see whether the first bit is 0. How in the world can I do that? Oh, wait, this is potentially a problem. I'm just moving a byte into RDI, whereas RDI is 8 bytes, right? 64 bits, 8 bytes. So yeah, so because this is gonna end up getting padded, right, with a bunch of zeros here, and then the first bit won't be 1 anymore. So that's not good, right? So what I need to do is something like this, no? Good catch. You can move SX. That extends the sign bit. Hopefully I haven't tested it. Is that in my cheat sheet? Where's like a new window here? It is not in my cheat sheet. It's probably lesser use. Let me look it up real quick. Move SX assembly. Let me get like NASM or x64 NASM. Oh, here we go. Wait, so there's move SX and move SXD. Oh, these are links to somewhere. Oh dear. I don't want to sign into this. So I'm moving into a 64-bit thing, and I'm moving 8 bits. So this is me, right? Move SX into whatever I'm moving into my value. Okay, so I'll try that. Move like that. Okay. Then up here, all right, now we should be able to check the first bit. How do you check the first bit? In x64 NASM, how can I check the first bit in a register to see if the value is negative or positive? The sign bit. Mod 10? You can check the sign bit of register to determine if the value by using the test. The sign bit is the most significant bit in the register. Here's how you can do it. Assume the value is in the RX register. Test the sign bit. What, you just use test? Yeah, I think modulo would get you that. Oh, it's actually modulo 2 you're saying. Because it's binary, no? What's this test? Okay, the test instruction performs a bitwise AND operation between the register and itself, which does not change the value but affects the flags. Jump if sign. Oh, there's a jump if sign. Checks the flag, the sign flag, SF. If SF is set, it means the value is negative. Okay. This is cool, assuming it works. So I have something in RDI, right? So I can test RDI against itself. And then, yeah, so 1, 2, 3, I would grab 3. Whereas we need to work from the other end, so we can't just use modulo. Exactly. Well, mod 100 will grab 23, right? Okay, so we'll do, so we'll jump if sign is negative. Something we're gonna make called is negative, which is right here. Negative. See, I've been using like dots in front of these. Do I not have to do that? Who knows? Let's try it without dots. Jump to is negative. And then otherwise, we'll jump to is positive. Or 0, right? And that'll be something right here. Positive. And this is cool. Those are both the do's. Oh, move SX doesn't work with immediate values. How did we get here? I was still at Hello World with Rust. Yeah, I kind of started learning assembly because it seems valuable for writing an operating system. Doesn't work with immediate values, so we need to not do this, right? So that's kind of what that table was showing, right? It was not showing immediate values. So should we try this? Put it into RCX and then do this. CL, I'm assuming, is the smallest part of RCX. The smallest 8 bits of RCX. Yeah. Okay. Just load the positive value and then apply 2's complement. Or you can just input negative 107 as a decimal value. So many possibilities. But you said I can't do it with an immediate value, right? So I need to have it somewhere. So I need to like move this. Move this into like RCX. Oops. And then move here. What was it? CL? Yeah, CL. If you have the quad word value, you don't need that. You can just use a normal move. But I still don't have the quad word value yet, right? Because this is sitting. I think this is correct, isn't it? I'm taking this, sticking it in RCX, which will give me a bunch of zeros here. Then I take the CL, which should just be the last 8 bits of this, and move it using SX into RDI, which will preserve the sign bit. Should work. Cool. Okay, I think it should work too. All right. So then, oh, this one will work because we're not using this. Okay. So test RDI. This tests the sign. Don't return yet, and then jump to here. So if it's negative, all right. Well, first we'll start with positive because that makes it a lot easier. If it's positive, then we get to just print it just like we did the other things, right? So I'm gonna use extern print char because I think we have that. I'm also gonna use extern. Wait, that might be all I need. Oh no, and extern print uint. Because first I'm going to fixture is positive label will be the same as your jump. Smart. Yep, good catch. Thank you. Print uint print. Okay, and then here we'll say just like print. Well, move into RDI. Could we get some? Yes. Okay. Man ASCII. What's the where's plus? Plus. That's an octal. That's not helpful. Plus right here, it's 2b. 2b. So I'm gonna go ox2b. This is a plus. And then we will call print char. That should just print the plus, and then we will move into RDI oh wait, we need to, because RDI currently has our number, so this would override it. That's no good. So let's push RDI maybe, and then over here we'll pop back into RDI, and then we'll then sorry, I'm kind of distracted. My family's outside my door talking about whether or not to shoot the raccoon that's currently in our barn eating our eggs. My sister's advocating for the raccoon's life. Okay, pop RDI. And then we need to, yeah, just call print uint. And that should just print the thing. And then we will return and be done. That should work. All right, and then if it's negative, we'll push RDI. And then move. RDI. We need a minus. Hey, your eggs. He's like, we're having coon for breakfast. All right, we need to find the one for, where's my other minus? Minus is 2D. Where was I? Right here. Minus is 2D. 0x 2D. This is a minus. And then I'm going to call print chars. That should print the minus. And then I want to pop RDI back off so we have it. And then now we need to, now we need to do the 2's complement. So that means I flip the bits, oops, jump up the mic, sorry. Flip the bits and then add 1. So surely there's a bitwise operator for that. Is there a bitwise operator in x64 NASM that flips every bit? So like 0, 1, and 1, 0. Not. Oh, how clever. Not just flips it. Okay. So then we'll flip it. So 2's complement. We'll do not RDI. This flips all bits. And then add RDI 1. No? That should work. I'm thinking. And then we have it, and then we just print, call print uint with RDI. And then, excuse me, and then this will be, then we'll just return out of here. Although we could also do the thing where we have like a end, and we return here, and then these just jump to the end. I'm not sure which is better practice. It seems unnecessary, right? Because I can just return there and there. All right. So this flips all bits, and then we add 1. Flip all bits. Use the tilde thingy. This guy. Two's complement. There's also the neg opcode, which flips and adds in 1. Oh, so neg just does this and this in one step. How do you do it? Like just this? What does neg do? Does it flip bits and add 1? Talk to me. Talk to me. There we go. Negates the value register or memory operands. It effectively performs 2 operations. Flips all bits, yep, and adds 1. But how do you use it? I just want to see this. Yeah, okay, so you just use it with 1 argument. Perfect. That's awesome. That's exactly what I want. So we just do that. And yeah, at this point, this could potentially work. It's unlikely, but it might. I say we just try it. I'm going to say Okay, cd assignments 1. All right, I'm going to nasm-f elf64. What is it? Print int dot asm dash o print int dot o. And then I'm going to link, and then the things it's referencing are also print char and print uint. So we have to link them all together, right? Print char.o, print uint.o, and print int.o, and then output print int. Uh-oh. Multiple definition of start. Oh, that's because, okay, yeah. So one of these, or two of these, have their own start. Print char doesn't, already got rid of it, so once we print uint. Sure enough, we need to get rid of this. I wonder if I could just, can I get rid of that? Would that solve the problem? And then try again. Oh, I need to now recompile it. Print uint. And then link them together. Undefined reference to print uint. That is probably because don't I need to make it global? Print uint. Compile print uint again and then link them. Oh, and it linked. Now if I print int, I get negative 109 and positive 7. That's exactly what I wanted, right? I was not expecting that to work. Guys, that was the first try. Print int. Look, negative 109 and positive 7. That's so cool. Wow, that's super fun. By the way, stream today, I'm planning on ending at 7:30 my time, so that's in like 42 minutes. But we'll see what happens. I have something at 8, so cool. That's super fun. I'm really glad that worked. Let's go to read char. Oh, reading. Now we're reading. Read one character at a time from standard in and return it. If the end of input stream occurs, return 0. I have no idea how to do this, so it's gonna be fun. Sorry, I got behind on chat a little bit. Anyon E, what's up, bro? You remember me? I did a comment on your last video. Which video? I'd have to see the comment, but I'm sure I'd remember it if I saw it. Have to leave for a little bit and okay, no problem. Sure. Okay, cool. So I'm gonna do the next one. And sorry, where'd it go? Oh yeah, so read char. Let me make a read char file. Read char. Maybe I should commit. I did all through print int. What have I done? Wait, I have another Git repository. Oh, it's because I cloned the source in. That's fine. Okay. We'll say like part way or wrote or like through assignment 1 through, oh dear, what happened? Assignment, did we manage to do print in? Yeah, we did. I'll show you in a second. Assignment 1 through, why is it doing that? Git commit -am. Assignment 1 through, okay. Print int assignment. Cool. Now it should be over here. Low level. Yeah, and the source is a sub thing, so you can't see anything in it. But my assignments, you can see. And here, for Stefan, here's a print int. It works. We put in, our test values were -109 and +7. And then when I ran it, like that, it totally works. See, -9, -109, and +7. Oops. So, oh dear, oh dear. Totally worked. Now we're doing rechar. .asm. And wait, let me quit out of here. Rechar. There we go. All right, so we'll have a global start, and we'll have a start down here. We'll have a section text, right? And this will do something. Like, and that, and that. Okay. I love how I'm just like swimming in a sea of Neovam errors this whole time. Cool. So then, how does one read input? So it says I have to read one character from standard in and return it. If the end of input stream occurs, return 0. How does one do this? One would assume there's like a read syscall. In x64 NASM, what's the number for read syscall? It's 0. Okay, because 1 was write, 0 is read, making a syscall. You typically place this number in the RAX. Yep, before invoking syscall. You might set it up. So you move 0 into there. Okay, 0 is standard in. 1 was standard out. Okay. And then you need a buffer to store the input in. So you need to make a buffer. Okay. And then number of bytes to read. That's pretty similar to what I think we're going to want, right? So I'll make like a, oh, this needs a colon there. Read char. So it returns it, so that means it sticks in an RAX, right? So I'll say call here, return. I'm going to call read char. And then I'm going to I don't know, do something. We need to print it, right? So let's import print char. We have a print char. Extern print char. Whoa, really? So you can do man syscalls. That's what you're saying. Looks like I don't have that. Or man to read. Sorry. So that works. But the other one didn't. Maybe because that's on Mac OS. Let's try it on Linux. Man syscall. This works. Let's check it out. Surely down here somewhere there's going to be a read. Oops. LMNOPQR. Here we go. Read. Read. That doesn't say the number. But we could man to read, you said? Read from a file descriptor. Hey, Mark. Doesn't give the number syscall, but it's still useful for documentation. Sure, that's cool. Yeah, but this does, right? It says whatever that means. And then the buffer count. Okay. It's useful. Alright, so Mark, we got the print int exercise working, which prints signed integers. Here, I'll show you real quick. So if I do print int, then I can print negative numbers and positive numbers, which is pretty fun. And then doing like the whole two's complement dance, right? So I don't even remember where that was. Print int. Yeah, so like this is negative 109, right? And then this is positive 7, and we're printing both of them. That's what we just finished. Thank you. And then now I need to figure out how to read from standard in, because the next assignment is read char. So I'm told by this guy here that the code is 0. So the arguments are really similar to write, but it's just they're just different, right? So in here you say like move rex 0, and this is for read, and then you move rdi 0, and this is for standard in. Standard in. Read from standard in. And then we need potentially a buffer to store the input in. Okay, that's interesting. We can do that. RDX, no, RSI is it, right? A buffer. And then, oh yeah, you just make that with the here, right? So section.data, and then buffer db0. So you're just making one, this just makes 1 byte. Okay. To hold it, which is actually what I need because I'm just doing one char. And then this like where to stick the value when we have it. And then rdx1 is the number of bytes. Okay, and then I have it. Move rdx1. This is how many bytes to read. We just want to do one char, so 1 byte, and then we syscall. Is that actually it for read char? Oh no, because I want to. Oh, I actually don't want to stick it in buffer. I want to stick it in my return value. So then after that, I'm going to move into RAX. Ooh. Question. I want to not do this because this would just stick the pointer to the buffer in RAX, right? But rather I want to say like the value in the buffer, you know? I'm going to move value in buffer to RAX. But this won't do it, correct? I think this would just move the pointer into. Does that work? RSI. Wait, what's RSI? RSI is this guy, right? Wait, I don't understand the this comment. Why that? Okay, so later if I want to stick the value in buffer into RAX, I can't just do move RAX comma buffer because that would stick the pointer itself in RAX. How can I get the actual value contained in buffer? You need to dereference. So it is that. So square brackets mean like deref. Is that accurate? Oh, and it's saying AL. AL is the lower 8 bits of RAX. Yes, brackets are deref. Okay, cool. So it's like this. And it's saying to use. I thought you could only do that for registers though. Oh, so that's why you were saying RSI, because buffer's already in RSI, and you said you could use the value in RSI right here instead, which would be the same thing. Okay, I got you. Assuming that's what you meant. But you could also do this. It's what this guy's saying. Well, we could try this, and then if it doesn't work, we know we could do that as well. My next question is, ChatGPT is saying that to use AL, which is the lower byte, right, of RAX. But if I don't, wouldn't this just like default to sticking it in the lower byte, or am I not correct about that? Could I just write RX here, or do I have to write AL? So this will return it, and then we'll have it down here. And then how are we gonna know? So we need to like print something so we know that we actually got it. So maybe we'll just print it. Oh look, we already pulled in print jar. So I'll move into RDI, RAX, and then I'll like print char. Call print char just to print it out. Let's see how this goes. I'm going to now run this. So what is it? Rechar, right? Rechar. Rechar.o. And then I'm going to link it together. RAX might read a quad word from memory, actually, not sure. You want to only read a byte. Okay. Well, let's try this, and if it doesn't work, then we'll try specifying just a byte. Okay, thank you. Link read char.o, but we're also referencing print char, right? So also print char.o, link them together into read char. I read char. It's waiting for me. If I enter something like an A or AS, L, that was very odd. It looks like it sort of worked. Read char. It just let me keep typing, and then I hit enter, and it took the A and printed it. So if I were to do that and just type M, hit enter, it prints the M. Is that what it's supposed to do? Like, am I supposed to have to hit enter? L, enter. Squirrely, enter. Yeah, it's kind of echoing me. Just took the first character you input. Yeah, the weird thing is that it's taking whatever else I input afterwards and like putting it in the standard in later. Like if I do lorem, it'll steal my L and then put aurum in here. And then if I do just an enter, it takes the enter and makes that standard in over here, which is why now I have two lines here. So that's a little bit odd, but maybe that's just how the shell works. Normal behavior for standard in. Okay. I nailed it. Thank you. So this did work. Mark, this thing here did work. So we can dereference pointers directly to memory buffers up here, which is neat. And I also didn't have to specify AL, which would mean the lower byte, because it defaults to sticking it in the lower byte, I suppose, which makes this easier for me. Cool, that's fun. Next up, we have, let me make this a little cleaner. Wait, sorry. There we go. Okay. Next up, we have read word accepts a buffer address and size as arguments. Okay. Reads next word from standard in, skipping white spaces into buffer. Stops and returns 0. Oh, wait. I don't know if we perfectly met this requirement. Read one character from standard in and return it. That's what we did. If the end of input stream occurs, return 0. What does this even mean? If the end of input stream occurs, return 0. Anybody understand what it's asking me to do here? They want you to fix the terminal weirdness, I think. Oh, is that what they want me to do? Seems like you get the end of stream byte wants you to return 0 in the return register. Is there like a specific byte that you always get at the end of the input stream? Because right now I've just been terminating it by hitting enter. is that, I don't know if that's right. End of input. That's not like an ASCII code, is it? End of something. Like, what are all these? Special control bytes. Can you check it's actually reading the number as char also? What do you mean by that? Depends on the OS, says Bacon. I mean, there's all these weird ones, like 0 through 32. I don't know. Um, 32 space. Oh, were those different white spaces maybe? That would make sense if some of those were white spaces. Okay. Well, maybe this guy can explain this assignment. Can you explain this assignment to me? I don't understand the part about what? The end input stream. Don't give the answer. Piece of code that reads a single character from the standard in. Wait, read one character. You need to read exactly one character from the input. This is typically done using a system call or library. Yeah. Return the character. After reading the character, you should return it. In the context of assembly, this usually means placing the character in a specific register or memory location that accesses the return value. The end of input stream refers to a condition where there is no more data to read from the input source. This can happen, for example, when reading from a file and reaching the end of the file, or when the user signals the end of input. Oh, like by pressing Control D. Return 0. If you encounter the end of input stream while trying to read a character, you should return 0 instead of a character. Man page says that it says read return 0 when it encounters an end of file, so you can. This was saying it's like the Control D thing, because what would happen to my guy? Or not that. Read char, right? If I did this and then I just Control D it, I have no idea what it did. Right? What did it return? So maybe that's the case it wants me to do, maybe? I don't know. We need Igor. I would guess that it would try to print an unprintable char. Yeah, test rx jump of 0. Yes. I wish I really understood what this was asking me to do. I mean, we could also just jump to read word. Yeah. Maybe I should just jump to, I only have like 15 more minutes, so maybe I'll just jump to this and yeah, jump to read word, and maybe this will clear up. And if it doesn't, then oh well, it's not a huge deal because I'm just trying to learn the assembly language. So yeah, I'll just do that, unless anybody strongly objects. So I'll do read word. Global start section text start, and sorry, XOR RDI syscall. And then, all right, so a requirement here accepts a buffer address and size as arguments. Okay, returns next word from standard in, skipping white spaces into buffer. Okay, footnote. We consider spaces, tabulation, and line breaks as white space characters. Their codes, oh perfect, gives me the codes. OX20, OX9, and OX10 respectively. Good to know. Cat's heading out. See you, cat. All right, stops and returns 0 if the word is too big for the buffer specified. Otherwise, it returns a buffer address. Okay, so that's pretty much, I think, is going to be it'll be like looping through read char, right? And just reading chars until the size gets too big, maybe? So yeah, that goes. So we're going to depend on extern read char. We're going to save ourselves some grief later by going ahead and commenting that out, and yeah, okay. Read word. So we have a read char. We're gonna make a function here called read word. This guy. So it takes 2 arguments. First argument goes in RDI, right? Second argument, where does it go? Where's my cheat sheet? This guy. No, this guy. First argument is RDI. Second one is an RSI. All right, so RSI will have the second one. RSI, RDI. Sorry, RSI. RDI, RSI. These are our first and second arguments. And then, so we'll move. So the one is buffer address and size. All right, so RDI will be the buffer address, and RSI will be the size. So we'll move RDI. We need a buffer, right? So let's make a word buffer will be that'd be a byte, right? Make it a quad word, maybe. So quad word is what? It's 64 bits, right? It's 8 bytes, I think. Dairy Queen. You should probably comment out the last line, the line that defines the global start in that other file too. Oh, thank you. Yes, smart. This one. Read word. How are we gonna? Okay, so then this guy takes the address to the buffer, so word buffer. So this is 8 bytes. 8 bytes. And then in RSI size, right? So 8. And then we will call read word, which does nothing but returns for now. All right, and then it'll put the return value in our AX, no? So what do we do with it then? Where's my... All right, I'm probably not gonna be able to finish this assignment because I'm gonna try to be done by 7:30. Accepts a buffer address. Yeah, okay, stops and returns 0. Oh, so it reads the thing into the buffer, but it stops and returns 0 if the word is too big for the buffer specified. Gotcha. Sorry, I'm gonna put my phone on Do Not Disturb. So it might have... Well, so let's make some check. Like if it's 0, if it returns 0, then we know that it was too big for the thing, right? It stops and returns 0 if the word is too big for the buffer. Otherwise, returns a buffer address. Oh, it returns the buffer address. Like the same buffer address it got, right? So we'll say, so our AX at this point now has 0 if it was too big for the buffer address. Hey, Artwork Studios. Welcome. So, oh, that's Ling. Hi, Ling. Yeah, Whirling from Discord. Cool. So here, I'm not sure what we'll do. Just like print the address or something. Well, we don't have something for printing those, do we? Well, we do have print int. We'll just print an int. Print int, and it'll be 0. Whoops. It'll be 0 if it was too big, and it'll be some other address, random address if otherwise, right? How does print int work again? We don't really need print int. We could just use print uint, you know? What are we doing right now? We're trying to do the read word assignment. This one. Oh yeah, we were checking how print uint works. Print uint. Looks like you just put an int in RDI and then you call it. That's pretty easy. So we'll just move REX into RDI and then we'll call print uint. And then maybe we should print a new line too to make it nice. Don't I have a print new line? Yes, and this takes no arguments. Okay. There we go. Extern print new line. We'll do that here. Whoops. What just happened? Print uint. All right. This should maybe go here for clarity's sake. There we go. And now we just need to bootloader. Nope, there's no operating system. anything really yet. I'm still just learning assembly. So okay, maybe this, it's almost 7:30. I said I was gonna stop at 7:30, so maybe this would be a good spot. Yep, learning user space as I'm currently. That is exactly correct. All right, I think I'm gonna call it here. So to do for tomorrow, will be fill this out, and I'll commit. Read char and part of, wait no, and started read word. Push that up, and yes, this is x64 NASM. x86 64 NASM. Cool. So yeah, thanks all for joining it. I'll stop it right there. Well, it's not actually on Mac Bacon because this is on a Linux VM, but yes, I am on a Mac, but I'm running this on a Linux VM. Cool. See you guys. I'm gonna stream again tomorrow. I think at the normal time, 6:30 EST. But I'll send something in the Discord, and I'll schedule it on YouTube so you can see it. Yeah. Until next time. Thanks all.